So I'd like to thank you all for coming today to the Science Circle for an early Darwin Day presentation. As you know, Darwin released this book called On the Origin of Species, and that was on February 12th. So we celebrate this as Darwin Day every year as an international celebration. And what I've been doing myself for the last, since 2018, 2019, I've been doing a hero of evolution. And what I want to say about it most in particular, and the purpose and goal of it, is to really celebrate someone, in some cases unappreciated at their time or still underappreciated, or um, from a very from a very historical point of view, really had to struggle to make their ideas and thoughts hold sway, but that in any situation contributes to the dissemination or the core evolutionary theory that Darwin originated. And so we've celebrated E.O. Wilson, we have celebrated Barbara McClintock, as well as Lynn Margulis, Christopher Dawkins, and so really some big luminaries in the history of Darwinian evolution and science communication. So this year, I felt there was a little bit of a situation and climate that I thought would be really worthwhile to take it a slightly different direction. And what we're going to do is not celebrate, but discuss probably one of the most important anti-heroes of evolution, whose impact is still being felt in the world. And so we're going to have Trofim Lysenko. Again, let me just ask a quick question. Anybody here know the term Lysenkoism? Is that a familiar sounding term? Is that something you might have learned about in European or Western history classes? Yeah, so Lysenkoism is obviously very directly related to what Trofim Lysenko did. And so one thing I also want to say is that I've usually done the Darwin Day talks on Darwin Day. And so this year, to fill in the Saturday slot, we're doing it early. And if you're not familiar, so you may not be familiar with my Darwin Day talks, I tend to be very science light. This is about celebrating usually the biography and context of a person. So that's what you'll see this time around. And so let's just begin. I'm Stephen Gasior. I'm actually a molecular biologist by trade, but I've also been an educator. Here I am in Second Life of Stephen Zootfly, and we're going to talk about Darwin Day 2026, Anti-Hero of Evolution, Trofim Lysenko, When Politics Trumps Science. Who was Trofim? So biography, born in 1898, he was among the peasant class in Ukraine. Graduated from a 2-year rural school in 1913, then the lower school of horticulture was his basic education. Went into a secondary school for horticulture. And again, this is something that in looking at background material on him, he really just always had a dream of being an agronomist. That was his childhood thing, you know. And so he ultimately did graduate from the Kiev Agricultural Institute and had a degree in agronomy in 1925. So his most well-known publications and early work that really defined his professional course was in 1928, talking about the effect of cold on cereal seeds. And he coined the term Jarovization. Although many people actually, this is something that was already well known as something called vernalization, but he had a take on it, and we'll talk about that. And then I have a yada, yada, yada. In 1940, Lysenko became director of the Institute of Genetics of the Soviet Academy of Sciences, another yada, 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 and then he died in 1976. So the yada, yada, yadas are the most important parts, but what we want to do is step back and take yeah, no, the yada yadas are definitely the most important part, but it's not a key. That's the key part of the talk, actually, not the biography. uh, but what I want to do is just step back and talk a little bit about context. And so let's talk Darwin versus Lamarck. Now, people are familiar with with the term Lamarck or Lamarckism, correct? People have heard this one before. Yeah. No, so people are familiar with Lamarckism, and because again, it's something that's usually taught in textbooks as the competing ideas that with Darwinian evolution at the time, and then most textbooks go on to say this is not how evolution actually works. And so the key features of Darwinianism that Darwin talked about was inheritance by descent, and that is who you are is defined by uh, the essence of who your parents were. And now, to be fair, he didn't have a mechanism for how that works. He had this thing called gemmules, which were actually existing throughout the body, and that those got passed on to the gametes in some way for that next generation. So he was, again, very unfamiliar with Mendelian genetics, as we now understand a lot of genetics as a basis. And the other key component part of Darwinianism is natural selection, which again, many times you've heard the term survival of the fittest. That actually was not Darwin's term, but survival of favorable traits and this selection for them is the key part about how species develop and evolve over time. And I saw it mentioned in local chat that, of course, Wallace was someone who was a competitor with Darwin and had very interesting analyses and trips to look at butterfly geography. And he had a lot of the same ideas about variation and how they develop, although he did not have as well developed a theory on the natural selection part. Uh, Now, Darwinian evolution ends up looking a lot like a tree. So I symbolically have put a tree with lots of branches, and that this is how species evolve. And then Lamarck, on the other hand, he had a couple of forces, that there was a directive as well as complexity forces that basically drove how species developed and how, uh, you know, different organisms on the planet evolved. And related to this is this idea of vitalism, which vitalism is just another way of saying supernatural spirit forces playing a role in directing how things go. But the representation of Lamarckism, which you'll see in a lot of old British papers or textbooks, and even through the 1900s, is that evolution is a ladder, and that there's this drive towards more and more complexity as well as more and more intelligence. And so, does anybody want to guess what species exists on the very top of the ladder according to the ladder of life? Yeah, humans. Yeah, Lily's right on top of that one. Humans. Yeah, Dolly points out dolphins would also be a good competitor, but humans, right? And so there's this very human and also in still a way religious centric way of thinking about how evolution works. Now, the other thing that Lamarckism is described as having is the acquisition of acquired characteristics. And Lamarck himself characterized these as the law of use and disuse. And so you can think of vestigial organs. We tend to think of the appendix as vestigial, or if you're a cave-dwelling fish, you have eyes that in some cases you see in species they go away. So you didn't use them and they went away. And now what's important to recognize here is that the key element of acquisition of acquired characteristics means that your environment determines what is worthwhile or not worthwhile for you to survive, and then that can be passed on to the next generation. Because the thing I do want to point out is that from the context of the time, Darwin himself did not dismiss that environment plays a role. Because if you observe speciation on the planet, it does look like there's this really good fit of the characteristics of species that fit their environment very well. So the question at the time was, do we necessarily know how the mechanism of, what are the favorable fittest characteristics? Why are they so well fitting to the population and species? And so luckily, science progresses, and what we describe as neo-Darwinism is basically the fusion of a few ideas here. So on the left here, I have August Weismann, who was a scientist who came up with germplasm theory. He was studying meiosis, and that is how organisms make things like sperm and eggs. And he very clearly was saying, look, genetics are passed on through these. And so these just store some genetics that are then passed on. These genetics are not subject to this environmental pressures within the genes themselves. And then he preceded Mendelian genetics, but then those were also rediscovered. And basically, that provided a lot of the understanding of the mechanism of how it actually works. And so, Barragon's mentioning, what is an unused trait, right? What is the explanation? And that is that typically, if you have an unused trait, there usually is an energy burden for you to make that. And so that's disfavored even within a selective pressure as just wasted energy. And so, and then also from a mutation point of view, you can just accumulate mutations that don't repurify it as being genes to keep. And so that's the modern day explanation of vestigial organs, or how things go away in different species, is that you don't need them, so you don't use your genetics to hold on to them. The other thing that was very important about neo-Darwinism at the time is that we started understanding from a population basis allele selection, selective pressures, and again, this very important term called population genetics. And so I've talked before about the Hardy-Weinberg equation, how we can measure and quantify these things. And so these became these very powerful forces that really had strong explanatory power for explaining how evolution works. And that's really what the majority of the world and the majority of the world's scientists were all developing around, are these very powerful tools and techniques of Darwinism. Again, another person to really point out was Thomas Morgan. Again, the unit of genetic distance is Morgan. He was a Drosophila geneticist, and he's a big name in the field at the time, too. Now, on the other hand, there was also neo-Lamarckism. Again, people were advancing this technology. What I have here is Paul Kammerer, and the image next to him is mating frogs. And he did an experiment showing that you can, within one generation of frogs, you can create this environmental pressure, and then you can see what happens in the next generation. And it does seem like there is this acquisition of acquired characteristics that fit this law of use and disuse. And there were a lot of other scientists doing similar types of experiments at the time. Now, in hindsight, there are some ways in which we think these things can work, and that they were looking at what are now called epigenetic phenomena. And there is an element in which epigenetic phenomena, which I gave a presentation on recently, kind of fits a Lamarckian way of thinking about genetics, and that's fair. But I hate to say it, most of the time people think what happened here is that these were just really bad science, that they were either fraud, and in one case, in Kammerer's example, there was a technician apparently committed some fraud in those experiments. So fraud on frogs is not great for developing a workable scientific theory. Yeah, no, and there's some mention in the local chat. Dubois and Java Man. There were so many people very excited to use Darwinian evolution to think, what was the missing link in human biology? And so these are people who got a lot of play and commercial success with frauds and whatnot. All right, other things were happening in the world at the same time. So a couple specific things relevant for today's talk. Uh, in 1910, Russian wheat constituted 36.4% of the world total export of wheat, although given the improving use of mechanization in agriculture, they were a little bit slow to catch on. They had other important crops like rye, oats, potatoes, and sugar beets. But I want to point out that Ukraine is known as the breadbasket of Europe. It is situated in some of the most fertile, great land for agriculture in the entire world. And they can be very productive, especially when you let the peasants just kind of carry on doing hard-working peasant things. 1914, you might have heard of this guy named Archduke Franz Ferdinand, who was assassinated. And so World War I was also a thing. Now, that of course disrupted agriculture, but to stay focused, we're going to accelerate to 1917, when there was both the February and October revolutions, in which communism basically took over from the czars, and then really tried to have an early treaty with the Central Powers, i.e., Germany and the Austro-Hungarian Empire, and basically ceded a bunch of land. If you look at this, there's actually quite a bit of very fertile land and subgroups that were ceded, including Poland and the Baltic states. 1922 is when officially the Soviet Union began, and Stalin was a central player in the major committees. And one of the things that really happened under the Soviet Union was the collectivization and class war against kulaks, which I put it in quotes because it's really hard to get a very solid definition, and different people actually use it for different situations. But kulaks would become a bit of a general term of we don't like what you're doing, so we're going to call you an enemy of the state, if not even a saboteur and a criminal. And this was in particularly applied to the peasants who were basically, they owned the land. That's one thing to keep in mind, is that the peasants at the time owned their own land that they farmed. In 1932-33, 5 million people died from a famine. And again, this was partly due to the collectivization of the farms, but also due to the environment and other conditions, but highlighting that in a very short span of time, this country went from being highly productive to also being subject to big distresses in their food supply. And so one of the things that was always a big focus for the government at the time is, how do we improve agriculture? Well, one thing that, in their minds is, let's have really smart people be in charge of this. And so I want to do again, related contemporary, really important figure, Nikolai Vavilov. And again, he was born in 1887 into a merchant family in Moscow. And again, I mentioned that because that's actually going to be an important point as we look at the contrast with him versus the very proletariat Lysenko. He traveled, so he became a biologist. I'm talking about where he got his degrees or anything, but he traveled Europe and studied plant immunity. He actually was a collaborator and kind of a mentee of William Bateson, who, of all the prominent people in the world at the time, he coined the term genetics. So he was probably a bigwig at the time, but he was performing very important science and contributing to it happening as a component of how we understand evolutionary biology and many other sorts of biological concepts. In 1916, he went around the world collecting samples of legume crop seeds in Iran. He was bringing this genetic diversity of cereals into Russia. That was his thought, is that, hey, maybe what Russia really needs is a diverse supply of seeds where we can tailor and breed the best traits and the best crops for what we really need for ourselves to feed ourselves. This is brilliant. This was in some ways also a very new idea. This is not something that people were really thinking about. A lot of times you just think, oh, let's just keep, farmers tend to be very conservative. So they tend to keep doing the same thing that they can over and over. What I have here on the bottom left part of the slide is a representation of his scheme of centers of origin, which is this idea that lots of crops became domesticated and or selected based on a geography. And then they really grew within that geography, and ends up being a concept that's true. In 1920, he was appointed the director of the Bureau of Applied Botany in Leningrad and promoted to the director of the Lenin All-Union Academy of Agricultural Sciences in Leningrad. Again, this is not just a university appointment. This was really his recognition that in terms of the government, he was the point man on improving agriculture for the entire country. And what he did, one of his innovations was creating a seed bank, right? Creating a place that housed, cataloged, had the ability to regerminate and regrow and study plant diversity by holding onto the seeds. And so he really gets the credit for being a pioneer in that area. All right, let's talk about at the time this tension that was occurring between Morganists and Maturinists. Now, again, this is another way of saying competition of Darwinian evolution versus neo-Lamarckism. But it's happening at the time from a political point of view, as Vavilov is trying to introduce more seeds and diversity, and Lysenko was publishing work and coming up through the ranks. Lysenko was invited to head the laboratory of vernalization. So I mentioned his Jarvanization idea. 1931, there were these resolutions to adopt Lysenko's work on vernalization, which would be for good and bad. In 1935, Lysenko, where's this coming from all of a sudden, compared his opponents in biology to the peasants who still resisted the Soviet government's collectivization strategy, right? Saying that these people who are scientists are opponents of Marxism. And there are some really nice documentaries on this, and this was actually video recorded. And you can see it's really amazing to watch. It's this old grainy black and white, but it's really, really powerful. Of Stalin was in the audience and stood up and said, "Bravo." And he's like standing there clapping by himself. And then suddenly everyone looks up and says, "Oh my gosh, that's Stalin clapping. We ought to clap too." And so there's like suddenly a rousing applause for Lysenko suddenly calling out people like Vavilov and others as being enemies, essentially, of Marxism. There's another key character in here. He was actually a lawyer, and then he made a shift to becoming a biologist, but his name was Sergei Present. And he was someone who started getting his voice out here at this point in time, too. And he was accusing geneticists of the classical school of supporting basically the opposition to the Communist Party. So again, creating this link of their enemies of the state. And another biologist, Alexander Cole, accused Vavilov of being a reactionary saboteur. And then in 1938, we had a publication called Improve the Academy of Agricultural Sciences and Ruthlessly Uproot Enemies and Their Rumps from Scientific Institutions, where it's calling out people like Vavilov again. So again, suddenly there's this, and it's like, oh, where'd that come? That escalated quickly. Type of problem for the scientists that were following what we now know to be the proper way of thinking about evolutionary biology. Present, again, to continue this, Present published an article on pseudoscience theories and genetics. So again, calling the Morganists and people like Vavilov that they were the pseudoscience. And other discussions in newspapers talking about genetics that, again, be very critical of Vavilov and the Morganists. And 1936 to mid-1940, Lysenko himself, again, being a voice in this argument, was repeatedly criticizing Vavilov and Mendelian genetics. And then ultimately, through the favoritism of Stalin, again, just a personal relationship. Stalin really liked this guy, and said, oh, let's make you the deputy director of this very important political group, the All Union Research Institute of Plant Industry. And on a trip to collect seeds in Ukraine, Vavilov was arrested. And this happened in 1940. Um, there's a story that goes on about his death. We're going to move on from that to continue the key elements of today's talk. But essentially, he died of starvation in prison after about 3 years. All right, so let's go to another main segment of the talk, which is let's actually just step back, and this is what I feel my role as a biologist is most important in these talks, is what was the science? What was happening scientifically that Lysenko was working on, and how does this fit with what we know today? And so vernalization, this is a concept that was actually well described by prior scientists all the way back in 1909. And so when you think about certain crops like winter wheat, is that you plant these in the fall, and these are adapted to overwinter in the ground, and then in early spring they germinate and emerge, and then late spring they blossom. And that is their life cycle. They are adapted to that life cycle. You can't take a summer wheat and plant it in the fall and have that work. It can't survive the cold. And what I'm also showing here is that if you were to take a winter wheat set of seeds and plant them after winter has happened and early spring, they're not going to germinate very well, and at best their development will be very slow, and you really just won't get any crop out of them, right? They're not adapted to this. They are expecting there to be a very long period of cold that is a signal for them to germinate. That is how they react to and understand their environment. Now, the concept of fertilization is that if you take these seeds, even if there's not been a winter, you soak them and chill them, and then plant them in the early spring, they will blossom and accelerate and act normal by late spring. And that is the concept of vernalization. Now, what Lysenko was claiming, though, was this idea of jarovization, in which in 1 year you can soak and chill stuff and then get a crop out of it, that this is now inherited. So that in theory, year 2, these things have now acquired this trait of growing and doing this thing of blossoming in late spring. So they now know this. They've acquired this characteristic. So in theory, you replant the seeds from from the progeny, and you'll get another crop that if you plant it after winter, and it'll be there late spring. You can imagine how amazing this would be, right? This would be a huge boon to Russian agriculture if this were true. But to remind you, this is not true. This is not reality. What the reality is that if you want this treatment to work, you have to be repeated. It has to be repeated. This is not something that is now acquired characteristic. It is a characteristic it has from its genetics, but it doesn't understand this from year to year just because it did something. So again, this is a very Mendelian way of understanding how it actually works. That's the key part. All right, one of his other major theories was talking about potatoes. And so the normal life cycle of potatoes, in spring, you have these things called seed potatoes, right? They're a potato. They're growing these little sprouts. We call them eyes. I don't think they look like an eye, but people call them the eyes. And then you plant them, and then from each one of these tubers, you can see like a whole burst of these. I was watching a bunch of people do potato planting. It's just amazing. You pull up from the stems, and you get a whole batch of these potatoes just from one being planted in the first place. And then from your harvest, you take some of these, you store them, and I don't know all the specifics on when you induce them to grow eyes or which ones you send for market or how all that works, but in essence, that repeats the cycle. Now, what was happening in the Russian potato crop at the time was there was this set of diseases that were coming along with them, and that there was this potato leaf roll virus, potato virus X, potato virus Y. And again, let's be clear, people didn't necessarily understand what viruses and whatnot were, but Lysenko was making the argument that they were just losing some sort of vitality. And that the way to treat this loss of vitality is to take all of these uh, seed potatoes and plant them in the summer. And that way they will get vitalized by the sun. And on top of that, to plant them really close together. He had this theory about planting either tubers or also when it came time for seeds, that a cluster of the same organism of their seeds or other body parts, they work together, they cooperate, they have some sort of, I guess, vitalism that makes them more hardy. And so what happens when you do this in reality? Well, you put them all close together, so whatever disease they have is more likely to propagate through them. They're not adapted to summer sprouting, and then you have a horrible crop. So this was, again, another example of Lysenko having an idea of how things work and making a suggestion, but it actually made everything worse. All right, well, let's talk about another really important concept in agriculture, this idea of hybridization. So what I'm showing here is this very kind of counterintuitive idea that was only really understood also again in the early 1900s, that if you have a very sickly inbred line of, in this case, maize, also known as corn, and then you have another inbred line, and again, you're breeding these are true breeding. Farmers will collect their seed and they'll replant the same seed year after year, so they're all being self-pollinated. You have these end up being these very weak inbred lines. But what we know in hybridization is if you take these inbred lines and crossbreed them, the F1, the progeny of that cross, has something called hybrid vigor. And we still don't fully understand how all this works, but this creates amazing crops. Now, the problem and the key element of this is that hybrid vigor lasts only for that cross. It only lasts for that one generation. And that if you keep self-crossing the result of this, then over time, those genetics get resorted out and you don't have as abundant a harvest and as hardy a crop as you did. And that's what you see too with these hybrids. They actually are more disease resistant, they're more drought resistant. It is a pretty amazing phenomenon. I'll mention the next slide, what's happening in the US, and this is some data from, you can see these historical trends all over the place, but the bottom line are the decades. The y-axis is the yield per acre of corn. And you can see that starting in the 1930s, something happened where we're getting an increase. And then now we're at this point where we're getting a dramatic increase of yield year after year with just the genetics of, again, this is entirely hybrid corn. And so, so tagline mentions hybrid vigor, regression of the mean. I don't think it's as simple as what you're talking about there, and we can talk about that later. It's very complicated what we do and don't know. But let me say, we know it reliably works, and you can actually breed inbreds over and over to discover the best hybrids. And this is something that I'll mention here. Hybrid was founded basically 100 years ago. So we have another birthday to celebrate by an Iowa farmer named Henry Wallace. And he founded a company called Hybrid, which then became Pioneer, and we now know as Corteva, which was a company that I did work for. And, there are lots of ways to think about how these yield gains that we have year after year have been important. And so, if you go from 20 bushels per acre and now you're at 180 bushels per acre, then that means you can make 9 times as much corn on the same land, or you can basically use 1/9 the amount of land to grow that same amount. And so Sumo asked Henry Wallace, the vice president. Yes, he was the vice president as well. Under Roosevelt or Truman, I can't remember. So again, now this is what's happening in the West, right? The West, the United States, Europe are taking advantage of true genetic understanding of how things work and applying these to their agricultural systems. And what happened with Lysenkoism is that he would argue that, okay, you can get these hybrids to work, but then now they've acquired this characteristic, and so you can just keep replanting the seed you got from your hybrid cross. And so again, this is not true, and this led to a dramatic failure in expectations for how much yield you could have from using hybrids. All right, and then there's another topic. How many people have heard of the Great Plan for the Transformation of Nature that came out of Stalin in 1948 after World War II? And what I have here is a picture on the left. The aqua color is the steppe of Asia, and there's just a subsegment of this. But what his idea was, and there's some precedent for this in the United States, that if you plant a bunch of trees to help break all the wind that's constantly coming through, then you can make your agricultural land more productive. There were other things happening too. They decided to divert some rivers from into the agricultural land as compared to going into the lakes, the Aral Sea, which now the Aral Sea doesn't exist anymore, pretty much. So is this anyone familiar with this? This is one of the biggest areas of I think hubris of man over nature in terms of one, the scale of the idea and the catastrophe of the results. So they were going to plant a bunch of trees. So the Lysenko link specifically here was that they wanted to plant a bunch of trees. And so Lysenko said, hey, plant all the seeds really close together. And then that had the opposite effect. The seeds did not mature into trees very often because that's not how seeds work. Seeds prefer to not have competition when they're germinating and gathering resources from the environment to grow into a tree. All right. So what is the underlying thing going on here, right? There's no necessary reason to think about offhand why Lysenkoism would be such a favored person and concept for communism, right? But this is what was actually happening at the time, is that this struggle in, again, what was at the time a very fair and true scientific debate of, is neo-Darwinism or neo-Lamarckism a true theory and description of how the world works, was contextualized by politicians. And so the characterization of capitalism versus Marxism, Leninism by Stalin and other Leninists was that capitalism represented being born with privilege, and that you were born with genetic determination. And again, to be very fair, social Darwinism was a concept that was happening in the West, and social Darwinism being this idea that, oh, if you're rich, you must have had good genes to be rich, and so you should keep being the people that are rich because you have good genes. This circular thinking about how the world works, and really this self-justification way of thinking about why your place in the world. And then one of the key elements, of course, of Darwinism was the struggle for survival was each individual. And this is something that, again, we think about pulling yourself up by your bootstraps, that you, as a capitalist, you're here to fight and compete against your fellow man to become not just a biological success, but an economic success. And that man is selected by his environment, right? So you don't control the environment more controls you in terms of whether you are the person who is successful. And when we contrast this to communism, well, everyone's supposed to be equal. Everyone starts out equal. And that the environment makes the man. And that the struggle for survival is because everyone has a class. Everyone's equal. We need to do this together, and we need to have the struggle because actually man can control the environment, right? And that this idea of communism changing the way the world works and people interact, how government and society and even science works, is that we control it, and that justifies communism as the best way to help the people. So again, either side probably not good to mix science with politics so intimately, would be one argument at the end. Uh, when they say, even after these decades of failure, Lysenko was rather unrepentant. Uh, Again, I have the full text here, and oh, sorry, I meant to share this. I will put the link to my slides here in the local chat very briefly. But that, in general, this basic idea of what Lysenko thought of his time, and what Stalin thought as well of his time, and how he'd been doing, was that they were doing great. Right now, again, some of this involves falsifying government reports, lying to people about how the agriculture worked. But in 1946, Lysenko kept criticizing Hunt's heredity ideas and his Mendelian genetics. In 47, he wrote to Stalin that those countries are not developed for agriculture, and that agriculture their science that they do serves eugenics and racism, and that agricultural practices and what they always called bourgeois genetics is what genetics was. It was something that the rich people played around with. In 1948, there was a big agricultural sciences meeting, and I just have this here of many speakers, again, continued to say, hey, we're great. All these capitalist genetics, they are horrible. It's all bad. And that really Lysenkoism should be the only correct theory. And again, this is another example of scientists being forced to denounce the work. If you were a scientist and you said something positive about Mendel or Morgan or Darwin, you could be imprisoned and killed. And that's something we saw in various purges. So preceding Vavilov's imprisonment, several Soviet geneticists were imprisoned or sent to labor camps or even sent in front of firing squads. That was how they treated people who disagreed with the state and the state's very specific sanctioned version of science. And again, one thing you even see at the end is that they make this, again, this is present, still saying stuff that, we are so right, we're just not even going to have discussions with the other side. Their science is just false and wrong, and they are aligned with the wrong side of the world. We're not even going to talk with them. So again, suppressing discussion. Now, one thing to point out is that this very intimate connection of communism to Lysenkoism was not contained to only the Soviet Union. That the People's Republic of China, under Mao Zedong, officially adopted Lysenkoism as their agricultural methodology. You might have heard of the Great Chinese Famine of 1959 to 1962, in which you'll see a wide range of estimates. It's really hard to get good documentation, but the estimates go from 23 to 55 million people died. And I've watched a few segments and video clips of some of what happened at the time and some of the associated aspects of how horrible the starvation was. Because if this is there were people who died, how many people suffered from malnutrition? How many generations suffered from malnutrition? How many people suffered through disease and debilitation of the lack of nutrition and calories? Again, the Lysenko connection, again, was this idea of close cropping. You sow seeds close together because they're more vital that way. They estimate that, in certain areas, they would have this concept of Jin per mu, which is the Chinese method of looking at productivity per land area. There's about half. That really reduced their productivity by about half. And so the concept of deep plowing was encouraged because that if you plow them really deeply, you'll get better root systems. But what's really important from those seeds is that if they like to be within 2 inches of the surface, that's how they make the best roots. You don't just dig them deeper. They need to have the right temperature, cycling of the sunlight That's actually what helps them develop, because that's what their genetics have adapted them to. All right. So with that being said, what we will do is recognize, we're specifically not celebrating, our anti-hero of evolution 2026, Trofim Lysenko. Things did change after Stalin died and Khrushchev came in place. A lot of this was, I wouldn't say purged, because Lysenko and a lot of these scientists, they were allowed to just kind of retire, re, get unappointed. They just kind of carried on thinking in some cases they're still right, but they didn't have as much power. Again, Lysenko did see a brief resurgence under Khrushchev because of some experiments that he did, but Khrushchev, he visited the United States. There's a great documentary showing him visiting the farms of Iowa and being like, what's going on here? This seems great. Um, but this is what Andrei Sarkov said about Lysenko in 1964. He is responsible for the shameful backwardness of Soviet biology and of genetics in particular, for the dissemination of pseudo-scientific views, for adventurism, for the degradation of learning, and for the defamation, firing, arrest, even death of many genuine scientists. And then then that's his quote. I should have put that, should distinguish this, but what I'm saying is, while it's hard to distinguish the specific contributions of what Lysenko was saying and promoting in terms of agriculture versus, again, you had bad weather some years. You had viral or other pathogens. You had bad policies, right? Collectivization and saying, we own your land and you farm it for everyone. Not necessarily a great policy for productivity. But that, if I think it's fairly safe that you could round upwards to 100 million died from starvation. And I think over the decades, especially when you include the progeny of people who are malnourished, that probably 1 billion people have suffered in some way or another from this insufficient food production, in which he was a major voice of how this happened. Again, along with just so much continued denial of what the real, true, and proper science was. Now, I do want to add on a little bit of a uplifting note that I do want to make an honorary mention for a hero of Darwin. Again, not official, but honorary mention of Nikolai Vavilov. You know, he really was considered this darling child of genetics, and everyone, the consideration of him was that he really truly was an exceptionally brilliant scientist. Uh, he went to international conferences. He was very well regarded. He was, again, considered a rising star, and his contributions to science were clearly cut short by unfavorable circumstances for where and when he was doing science. And so I think let's just also take a quick moment to recognize that there were a lot of scientists, you know, in the hundreds, maybe even the thousands, who correctly supported and voiced their support of true genetics, and again, maybe for other reasons as well, but they were arrested and sent to labor camps and put to death. And there are lots of, I'm just naming a few here that were available. So I think there's an important, you know, lesson for our time in this. Again, one thing I will put out, and I meant to do this ahead of time, is give you a list of my sources that are available. I'm going to throw in a few quick links here that you can look at for further edification of interest in this topic. There's some documentaries about what occurred at the time. There's a friend of mine who has a science-based medicine blog and talks about, I think, what are some modern contexts for this. So first of all, I definitely want to thank Wikipedia. A lot of my Steve Novella from The Skeptic's Guide to the Universe mentions David Gorski quite a bit, and that science-based medicine is a part of Novella's efforts to do this. But the particular link that I have here, I think, was written by Dave Gorski. So yeah, since I'm mentioning it, Skeptic's Guide to the Universe is a great place to listen to people talk about how to digest scientific news in today's world, both the good, the bad, how you as an individual can parse through misinformation, false information, as well as does a really nice job of highlighting really interesting, relevant news that is true. That is true. And I guess I'll also thank all of you for coming and attending today. So remember, February 12th is official Darwin Day. I gave you the link for Darwin Day International Celebrations. I'll post that here again. See if there's something you can do, because I think what we really need to be ready to do is to celebrate science, celebrate it in the right way, and support scientists for doing what they do. Because let's face it, there are consequences. I think what Lysenkoism proves more than anything else is that there can be extremely dire circumstances that occur when we promote and follow bad science. So thank you all for your attention today.